Okay guys, today we are starting chapter 9, 9.1, solid figures and 3D shapes. Today we're going to identify and name solid figures. So this is our bell ringer. It's a flashback to when we named figures by the number of sides. So we're deciding how many sides each of these have. Well, our first one up is a quadrilateral. Remember, quad, like quarter, means 4. Then we have hepta. This was the most forgotten one on our test. Hepta, that's 7. Penta, like the pentagon. I know the word is pentagon, but it means 5. Octa, 8. And hexa, 6. Okay, so we have polyhedron, a solid formed by polygons. So the parts of a polyhedron are the faces, the flat surfaces, the edges, the segments joining the vertices, and the vertex where edges meet. So you see here you have a vertex. I should have done this in a different color. Give me a second. So you have vertex, or vertices, where all the edges meet. You have the edges that are joining them. I'm missing some of those lines. And then down here. Okay, and then you have the faces. And the faces are hard to shade in. Those are the flat surfaces. So you have a face here, a face here, a face here, a face back there. Then you have the top and bottom. And then here's a good picture of it as well. Okay, we now have the definition of a prism. It's a type of polyhedron that has 2 congruent parallel faces. Name prisms by their base. So our examples here is we have a hexagonal prism would have a hexagonal face. And then in your pictures you see this is a triangular prism because the shaded ones are the faces. And they are triangles. All the other sides are rectangles. Over here you have a rectangular prism. The 2 bases are rectangles, so the sides are rectangles. And then you have a pentagonal prism. The 2 bases are pentagons, and all the sides are rectangles. Again, pause these as needed. Here's our list of prisms, our types of solids. So we have a rectangular prism, rectangular base, triangular prism, triangular face, cubic square prism, or let's try that again, square prism. We also call it a cube. We have a cylinder and we have a cone. We have pyramids. Our pyramids, notice that they have triangular sides. So we have a rectangular pyramid, a triangular pyramid, and a pentagonal pyramid. And all of those have the base as the shape that they're talking about. So rectangle, triangle, pentagon. And then you have a sphere. So is this a polyhedron? If so, identify the shape of the base and then name it. So if we look at this first one, you see that all of the sides are formed by polygons. So yes. I need to put it back in marker mode. Yes. And we know that the base is a triangle. The sides are rectangles, so we know this will be a triangular prism because prisms have sides that are rectangles. Our next one is this shape going to be a polyhedron. Well, the definition of polyhedron from our first slide said it's a solid formed by polygons. And we know circles are not polygons. So no, we know it's a cylinder. But a circle is not a polygon. Okay, our next one up. Name the polyhedron. Count the number of faces, edges, and vertices. So you see the sides are rectangles, so we know it's going to be a prism. We see that the base is a rectangle, so we call this a rectangular prism. And then how many faces does it have? Okay, so you see you have 1 over here on the side, 2 on the back, 3 on the other side, and then 4 up front, 5 on top, and 6 on bottom. So it has 6 faces. You can picture this one like a cardboard box or a shoebox. Now we had to count the edges. So 6 faces. Let me go over here. Let's erase. Now let's do our edges, I guess. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. Okay, and then let's count our vertices. So that's where the edges meet. So we have 1, 2, 3, 4, 5, 6, 7, 8 vertices. Okay, count the number of faces here. So we have 1, 2, 3, 4, 5. So 5 faces. You see that the faces all, or the sides are all triangles, so we know it's going to be a pyramid. We look at the shape of our base. It's a rectangle, so we call it a rectangular pyramid with 5 faces. Let's count our edges. One, 2, 3, 4, 5, 6, 7, 8. 8 edges. And let's count our vertices. 1, 2, 3, 4, 5 vertices. Okay, I think that's all we need to do for today. Actually, that's not true. We only have one example left. So I was going to split it into 2 days, but we'll finish it all. Okay, so here we go. We now have Euler's formula. That's how you pronounce that. And it's faces plus vertices equals edges plus 2, where F is your faces. I'm writing, but it's just not doing anything. Okay, there we go. Where F is our faces. These are vertices. And E's are edges. So here is a dodecahedron with 12 faces and 30 edges. How many vertices does it have? So if we know that the formula is F plus V equals E plus 2, we know it has 12 plus V equals 30 plus 2. So that gives me 12 plus V equals 32. Subtract over 12. We know that V equals 20. It has 20 vertices. Okay, guys, try your homework. Miss you. Bye.